So, we are going to have a quiz tomorrow. You may use a calculator, but please note if it says exact value, I need an exact value, whether it is a square root of something or something of the sort. The quiz looks just like this, new numbers. So this is what you want to study. My mantra is, if you can't repeat it, you're not ready. So try it yourself. After we do it, does not mean you're ready to go. Do it again. Can you repeat it without looking at the answers? You'll have the answers. Make a new copy that's blank. Can you repeat the process? If you can repeat it, you're ready. If not, repeat it again. If you still get it wrong, watch the video again. Studying math it's like a sport. If you don't go swing the bat, you're not going to be a better baseball player. Math is something that is an activity. You have to do it and see the patterns. You have to practice. That being said, let's take a look at number one. The rule is, if you want to take something from degrees into radians, all you got to do is you got to take the degrees and you tack on a pi, you put it over 180, and then you reduce. So that's the rule of thumb that you want to take. If it's in degrees, tack on a pi, put it over 180, and reduce. I want it in exact form. Even if you can use a calculator tomorrow, I need it reduced. So in this particular case, it would be 700 pi over 180 would be your first step to find the correct answer. It is a multiple choice. Tomorrow it is not. It's just do this. If I notice that the top and the bottom are both divisible by 10, or 5 and 2, any of those things, I do divide by 10 first. So that's 70 pi over 18. I still notice that 70 and 18 are divisible by 2. 180 is only divisible by 2, 5, 3, or multiples of those. So, you kind of can narrow down because of the 180. If you divide the top and the bottom by 2, you get 35 pi over 9. You can't go further than that. That is the answer. The answer is D. Okay. So that's what I'm looking for problem number one. Please put the degrees into radian form. Okay. Now, problem number two is taking the degrees, decimal degree, or writing the answer in decimal degrees. That is degrees, minutes, and seconds. So you find that in navigation. You find that in a GPS. Any type of pilots, a naval vessel, any of those things will use this type of measurement. What do you got to remember? Well, this is minutes and seconds, and that's going to kind of give you the conversion. It's by 60. So all you got to do, and you'll have a calculator tomorrow, is take 122. That's 43 out of 60. And this one is 12 out of 60 squared. Now, 60 squared is just 3,600. So feel free to write 3,600 or 60 squared. And just throw that into your calculator. You have an ABC button, but you can even put the division. It says to the nearest thousandth. 1,000 is 3 decimal places. So let me tell you what the answer is there. The final answer is 122.720 degrees. Okay, so just remember, this place you need 60 of them to make a degree. That's why we divide by 60. This place is the next 60, so it's a 60th of a 60th, and that's why you use 60 squared. Okay. Anybody have any questions about 1 or 2? Okay, let's take a look at number 3. Coterminal means that it lands in the same spot. So we're gonna to see where it says identify all angles. Let's just go 2. So we're going to do a positive version and a negative version, okay? So we're going to take plus or minus 360 if it's in degrees, and I did leave it in degrees. If it was radians, do 2 pi. So all you're going to do is you're going to do 480 plus 360. 480 minus 360. And that's going to give us 2 spots that are coterminal with 480, that lands us in the same spot. 480 plus 360 is 840 degrees, lands us in the same spot. 480 minus 360 is 120. That also lands us in the same spot. So if we were to draw out 480, 840, 120, they all land us exactly in the same spot. Okay, so that is number 3. Number 4, the word I really want you to get into your brain, that exact value. Anytime they say exact value, please note that I want that square root form if that's something we need. Please note also this is a right triangle. Right triangles, we are allowed to use SOHCAHTOA and Pythagorean. So the first thing we do is we need all 3 sides. So this is our hypotenuse, which we'll call C. And remember that a squared plus b squared equals the hypotenuse squared. And so 3 squared is 9, 5 squared is 25, 9 plus 25 is 34. So C is the square root of 34. We don't need that plus or minus in this case. 34 is 2 times 17. Neither of those things can be simplified when under a square root. So that's the way you leave it. So when it says exact value, if you give me a decimal answer, I'm going to mark it wrong. It's not the exact value if you've chopped that decimal off. So please give me that exact answer. Now that you've found that, let's label our sides. So this is our adjacent to theta, and this is opposite of theta. So now we've got all 3 sides, and only when you have all 3 sides can you go about doing the 6 trig functions. So now let's do sine of theta, cosine of theta, tangent of theta. Now remember, if you just go SOHCAHTOA, you got those. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So that's why we need all 3 sides, and we label all 3 sides. Okay, so the sine is opposite over hypotenuse. That's 3 over square root of 34, square root of 34, which is 3 radical 34 over 34 when rationalized. So that would be the answer I would want for the sine of theta, 3 radical 34 over 34. Now the cosine is adjacent over hypotenuse, so that's 5 over the square root of 34. So that's 5 radical 34 over 34 when rationalized. So remember, to rationalize the square root is pretty nice. Just pop the square root to the top and leave the normal number without the square root on the bottom. And then tangent is opposite over adjacent, and that's just 3/5. Now, once you have those 3, I still need the 3 reciprocals. So you got to memorize that order so that you get them right. The sine goes with a cosecant. Cosine goes with a secant. Tangent goes with a cotangent. Okay. So I don't know if it helps you to remember that sine and an S and a C go together, and then these ones just kind of feel right that they go together. Flip over whatever version floats your boat. I think this is a good version for that one because that would put the radical at the top. So that's square root of 34 over 3. This is a good one to flip. That's square root of 34 over 5. And this is a good one to flip. Well, that's the only one, but 5 over 3. Okay, so exact value, I do not want a decimal form. I will take points off for that. Please give me, using the Pythagorean theorem, the exact values. Do we have any questions about question number 4? Okay, now there's one like number 5. There's not much from that 7.2b that I'm super concerned about, but I do want you to kind of know the relationship between a revolution and a radian. That's an important one to know. The Greek letter we see in problem number 5 is omega. That's an omega symbol. I think of it as like a little rounded squished W, but that's an omega symbol if you wonder. It says find the rotation in revolutions per minute given an angular velocity of pi over 3 radians per second. Now we're going to do something that you do in a science class where you kind of get the units to be what we want. So I'm going to put pi radians over 3 seconds. I'm just going to kind of put the radians per second. So I'm going to put radians up at the top, seconds at the bottom, whatever numbers were there, just go along for the ride, okay? Now the conversions, we're going to make it 2 conversions. You'll notice that our units here are revolutions per minute. So we need the seconds to become minutes. That's a pretty nice one. 60 seconds is equivalent to 1 minute. So we need the seconds at the top to cancel out the seconds that are in the bottom. That's the way you can tell to put that seconds in the top. And so that would leave our minutes at the bottom. So that would cancel out our second units. So that's the first thing we do. We multiply by 60. And now we're going to need to cancel out the radians. So it needs to go in the opposite locations with revolutions. Okay. Now, 1 flip around the circle is 360 degrees. 1 flip around the circle is 2 pi's. So a revolution is worth 2 pi radians. If we did a revolution to degrees, that would be 360. But 1 revolution is worth 2 pi radians. 1 revolution around our unit circle is worth 2 pi radians. So all we're going to do to simplify this is we're going to multiply the stuff on the top. We're going to multiply the stuff on the bottom, and then we'll simplify it, okay? If we multiply all the numbers on the top, because now our radians have canceled, we are left with the revolutions per minute. That's the way that, there's a name for this in science class. Does anybody remember what that's called? There's a name for it, right? Yes, and I can't remember what it's called. Anyway, I'm not a science teacher. There is an official science name, but anyway, let's multiply all the junk on top. Pi times 60 times 1, we're just going to write that as 60 pi. And 3 times 2 pi is 6 pi. And you'll notice we have revolutions per minute. Now, the pi's are going to cancel. Even the one on the quiz tomorrow, the pi's are going to cancel. I did leave it a pi in there for you. And then 60 divided by 6, if you can't do that in your head, just put it into a calculator. You can use a decimal for this one. It doesn't say any kind of exact value. 60 is divisible by 6. It's 10. So it is 10 revolutions per minute. So the 2 conversions you need to know, it's 60 seconds that makes a minute. It's 1 revolution is worth 2 pi radians. Okay. So, and memorizing the unit circle should give you this one, hopefully. Okay. Problems on the second section here, this problem 1 and 2, see again where it says exact value. For this section, you're going to use the unit circle. Please use the unit circle to do this. Now, where is the unit circle when you take this quiz tomorrow? It is in your brain. But if you want to draw a picture as to where something lands you, that's always been something. I kind of picture it in my brain because I've seen the unit circle so many times. But for you guys, if you want to draw the little section on the paper, that's always a good tactic. 210 is divisible by 30. It's the 30 that's right here. Remember, that is the point, negative square root of 3 over 2, negative 1/2. So by drawing that little picture, what is the point at that location? It's pretty easy then to answer the question. So the cosine of 210 is the x value that we find at the 210 location on the unit circle. So the cosine of 210 is negative square root of 3 over 2. It says exact value. You will have a calculator tomorrow, but if you give me the decimal for that, I think it's something like 0.8 something. If you give me the decimal for that, I will mark it wrong because you need to know that 0.866 is square root of 3 over 2. Tangent of 3 pi over 4. Let's do the same thing. 3 pi over 4 is the 45's in the second quadrant. So that is right there. It's like 135 degrees, I believe. That is the point, negative square root of 2 over 2, positive square root of 2 over 2. Okay. Now, tangent, remember, is y over x, or opposite over adjacent. On the unit circle, it would be y over x. And so if we did positive square root of 2 over 2 divided by negative square root of 2 over 2, anything divided by itself is 1, but a positive divided by a negative is negative 1. Okay, so for the bottom number 2, the answer would be negative 1. And you can do that trick, big C over little c, if you want. Feel free to do that. Okay, any questions about those ones? So the last question on the quiz tomorrow is about the trig functions related to a point in space. Okay, this also requires exact values. Please note, if you give me the decimal value you find on a calculator, I will mark it wrong. Okay, so how are you going to do this one? Ignore the little 4 there. It was just the bottom of the page, I think, when I cut and pasted this. Anyway, draw an XY axis. Draw the point 4, negative 5, which is 4 to the right. And put on that point in whatever it lands you in space. Okay. Now, we always want to follow the same technique when doing this. Please connect to the origin. That's your first step. Connect to the x-axis. Make your triangle. Put in your theta. Okay, let me say that again. You always connect the same exact way. You connect to the origin, connect to the x-axis, make your right angle measure, mark your theta. Okay, always. The adjacent is always the x value they gave you. The opposite is always the y value they gave you. The radius or hypotenuse is always going to be found using Pythagorean theorem. So they will never give you the hypotenuse in this particular situation. They're going to give you the x and the y, the opposite and the adjacent, but they're not going to give you the hypotenuse. So we know that r squared is this, well, we can even go further. If you just square root x squared plus y squared, you got it. The sum of x squared plus y squared. So it's just Pythagorean theorem. Okay, so that's 4 squared. That's 16. Negative 5 when you square it is 25. The square root of 16 plus 25. 16 plus 25 is 41. And that is not a square root that we can do anything to. 41 is prime. It doesn't break down. There's no perfect squares living in there. Okay, so now we know our hypotenuse. So now we're ready to do exactly, it becomes exactly like the problem we did for number 4, because now we have all those pieces. So now we know that the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. You can also think about that as y over r, x over r. And then our tangent is always y over x, or negative 5 over 4. Now, the first two, let's not stop there because we haven't rationalized those. So pop that square root up on the top next to the negative 5. Here, pop that square root up by the 4. Leave a normal 41 behind. Okay. Now that we have those 3 exact values, then you're going to give me the 3 reciprocals. Okay. So cosecant. Again, usually that first setup, if it had a radical in the bottom, if you flip it, it's now going to go in the top. So that's negative square root of 41 over 5. Just put the negative at the top. Sorry, it's so ugly. And then our secant would be square root of 41 over 4. And then our cotangent is negative 4/5. Now, the best way to prepare for a quiz is to repeat the process. Open up this paper by yourself without the answers on it. Can you do it again without looking and repeat the process? If you can, you're going to be ready for the quiz. If you can't, do it again with me for the video and then try again. Repetition in math is pretty helpful. So when I was a youngster like you, if there was a concept that I needed practice on, if I practiced it, I did better. It's like anything else. The more hours you put in, the better it's going to go, okay? So this is what the quiz looks like. It's this very same format. I'm not doing anything different. So if you followed along with that, then you're good to go for the quiz. So please at this time, turn this in. You should have turned in a worksheet on Monday. If you haven't taken your unit circle quiz and you want to do it right now, that's fine, or come and see me at lunch. I hope to have those graded sometime soon here. Again, I'll try my best. So there you go.